Alright class, welcome to 4.4. In this lecture in 4.5 we will be discussing Adams and Webster's method. Again, Quincy Adams is President of the United States, or previous President of the United States. Webster, Noah Webster, if you know anything about him, he published the dictionary that was used in the schools for almost 100 years. So Noah Webster, again, two very prominent people in politics as well. And so they came up with their own methods. Just real quickly here, just so you know, we covered the Jefferson method earlier. So this is really just a modification of the Jefferson method. Nothing new. 4.4 should be pretty easy as long as you understood the Jefferson method. So let's jam with it. So first proposed in 1932, it was a counterpoint to the Jefferson method. Basically, instead of using the lower quotas, you're going to use the upper quotas. So exact same process, exact same things that you're going to be doing, just you're going to round up always. All right, and that's it. There is your Adams method. And so if you want to go through a quick scenario here, so Adams method. The divisor is D. This is Parador's Congress, if you guys remember from the last section here. So the standard divisor was 50,000. And in that one, let me just look up what we used in that one. If you want to kind of flip back to 4.3 lecture or in your notes here, and you want to go to the Parador's Congress, Jeffersonian method, we used 49,500. That was the example given. 49,500. In this case, remember you want to adjust your standard divisor. So in this case, since we're always taking the upper quotas, you want to make the denominator bigger because you want to show less seats here. So let's go for it. Let's see if we can look at some numbers here. So let's make a guess. But let's go for it here. So here's your population. I've seen these numbers before in the last section here. We add all these up. There is 12,500,000 seats, or total, right? We divide that by how many seats are there, 250, and it turns out it's the standard divisor is 50,000. And so our first guess is, since we're taking always the upper quotas, let's go up by 500. So notice 32.59, it just rounds up to 33. So whatever this number is before the decimal, you just add 1 to it. So 137.35, who cares? We're taking the upper quota, so we're always going to use the rounding up method. 3.05, round up to 4. 41.41, round up to 42. Okay, as we do that, and as we add these up, it looks like we're just a little bit too or not enough. We're over. There's 250 seats, but we have 251 seats as of right now. So let's modify that again. Let's move, and the book goes another 200. So now we have 50,700. And when you do that, again, round up, keep on rounding up, and eventually you wind up with this. So we add them up, you get 250, and you're done. So good. Only difference is you round up instead of rounding down. That's pretty much it. Okay, so new computations are shown in the last two columns on the table, previous slide. The apportionment under Adams method is given in the last column of the table. Okay, the good news is there are plenty of other D's that might work. So in fact, it'll give you a range. Whenever you look at the back of the book, I believe, for the answers, it'll give you a range of all the divisors that would have worked. So 50,628, that was the bottom number that would have worked, all the way to 50,999. All those divisors worked. The one that we picked from the previous problem was 50,700. So yes, that is in that range. All right, so Adams method. Find a suitable divisor. You modify up each time, and you always look for the upper quota. All right, Daniel Webster, he proposed, hey, hold on, how come we're rounding down, and then how come we're rounding up? why don't we just use rounding like it's normally should be done? So if it's 0.5 or higher, you round up, and if it's less than 0.5, you round down. That looks so easy, makes sense. So that's the Webster method here. So find the suitable divisor. As you portion it out, just round like we normally round. It's called conventional rounding, or rounding to the nearest integer. So a quick one again here. Parador's Congress, here we go. Standard divisor is 50,000. And since we're going to be rounding up some of them and rounding down some of them, your standard divisor and the divisor you're going to use is not going to go that far away. It'll be pretty close. So 50,100 is what we're going to try. So with 50,000 only, as you do this, and it's just going to be regular roundings, right? So 0.92, that's pretty close to 33. 0.72, that's going to round it up. 3.08, that's going to round down. It's not halfway. That's over the halfway marker. That's over the halfway marker. That's over the halfway marker. And as we round it all, or sum all the different answers here, we're 1 over. So we have to make our denominator just slightly bigger. And so as we could go from it here, that still stays at 32. But this one here, notice it's this seat right here. It was at 0.72. As we used a higher rounding method, that one came under 50% now, and now it's at 138. Okay, all the other ones stay the same. That one stays the same. This one stayed the same. That one stayed the same. So then eventually, as you add up all these, you get 250, which is done. Okay, again, is 50,100, is that the only number that works? No. There's going to be a little spread. And it could have been the 50,200 might have worked as well, or maybe 50,050 or 50,025. So there's no kind of set number that's sort of here. So the homework will always going to give you a range. All right, let's go to our homework. So these are the ones you need to turn in. If this is a hybrid day assignment, this is the ones you need to turn in order to get credit. So find the apportionment under Adams' method of the Margarita Congress described in exercise 10. So over here I kind of gave you the exercise 10 on the side. Express the modified divisor in terms of percents, okay, of the total population, and look for suitable divisors. So as you add all this up, it kind of gives you a hint. It says, look, actually just divide it by 0.81 all the way to 0.82. So you can do 0.81, 0.815, you could do 0.818, you can do 0.819 would work, or 0.82 would work. Any one of those would be suitable divisors. They're already saying what's going to work. And so let's go with it here. So if you want to take each of these numbers right here, 6.24, you divide that by, and let me just see which one the book uses. The book uses 0.814. Again, you could have chose slightly different numbers. That's what the book does. That's what the book uses. And so we're going to go back real quickly here. So on your calculator, just kind of have a calculator handy. So 6.24, you divide that by 0.814 as your divisor. And punching that in, you should get 7.67. All right, and then you do the next one, right? This is going to be 26.16 over 0.814. You do that, and you should get 32.14. So keep on doing that for the rest of the numbers. And then we're going to just round. So this is Adams' method, right? Adams' method is we always want to take the upper quota. Upper quota always. So 7.68 is going to round up to 8. Oh, sorry, 7.67 will always round up to 8. 32.14 rounds up to 33. That rounds up to 35. That's pretty close as well. And that rounds up to that. And so with that, let me go back right over here. There are 125 seats. in the Margarita Congress, and let's see if that adds up to 125. I'm going to use my little calculator just real quickly here. So I am adding up 8 plus 33 plus 35 plus 49, and that's 125. So off to the side, this plus this plus this plus that gave you 125. That means we are done. Okay. The reason why it helped is because they actually told you which divisors would work already. So that's kind of nice. All right, if you used 0.1, let's see if you've used 0.81, so if you actually divided by 0.812, that would have not worked. You would have been just a little bit shy, but it looks like 0.813. So anything from just write like this, anywhere from that number to that number as your divisor would have worked just fine. All right, on to the next question. So find the apportionment under Webster's method. And we're going to use something else. We're going to use the Tasmania State University description from exercise 6. So as we look to exercise 6, all we really need to do is to get these numbers right here. That's all. So remember at number 6, this is the standard quota already given. You had to work kind of backwards in 46, so we don't want to work backwards here. We want to do the Webster method, knowing the answers already for number 6. So let me get the answers for number 6. I think it was this. So the number of faculty positions is 250, and so the standard quota was 50. And then the answer for number 6 is you kind of spread out your answers for number 6 for C. All right, what we want to do is we want to know that the standard division is 50. There's 250 positions. And so we have to kind of nudge it a little bit, maybe a little bit up or a little bit down by that. So try it. In fact, 50 does work. So the answer for number 6 does work as well with the Webster method. And again, like I said, the Webster method, since you're rounding, half of the numbers go up, half of the numbers go down usually, you're not going to move a lot from your standard divisor. You might hit it just right. So the standard divisor that worked all the way in 4.1 is going to work just perfectly for this one. Sometimes you'll have a little bit of a leeway here. So 49.79 all the way to 50.14 would work. Any one of those would work just fine. So the book uses 50, and so that's the quota, right? And number of faculty positions here. So you set it up, and you have to use these numbers here. So 1646 would go under agriculture as your kind of your numbers again, right? And then 762 would go under B. But what happens is this: when you divide, because we're still using the same divisor, it goes back to these numbers right here because we're using the same divisor. So in 38, what you just only should kind of realize, like, you know what, if I'm going to use my regular divisors, I'm going to use those. So if I round 32.92, that's close to 33. That's more closer to 15. 41.62 is closer to 42. 21.32 is close to 21, and then 138.9 is close to 139. If you add these up, 33 plus 15 plus 42 plus 21 plus 139, voila, it ends up to be the exact number of faculty positions that are there already. And so we're done. So the Webster method is kind of useful in the sense is you're just using the regular rounding techniques that you normally would use, but you're trying to figure out the divisor that would make sense. All right, and jumping to 4.5, this is the HuntingtonHill method. Originally it was called the Hill method because this person named Hill did it, and then Mr. Huntington came along. I believe it's the 1940s, and they finally standardized. Actually, let's go through it here. So 1941, right before, a little before World War II, or we entered into World War II, we had this method in which we either used the Jefferson method, we used the Adams method, or we used the Webster method. And every 10 years, Congress pretty much decided which method they wanted to do. So sometimes it would have been, it was really number crunching right before the census date. Once they found that out, then there was you had a vote on which method we're going to use, which divisor you're going to use. So it was a lot of debate at that time. So what happened in 1940 is we came up with the standard method. This is the way it's going to happen. It's not going to change anymore. And so the number of seats in the House of Representatives in America is set at 435, no more, no less. And then the method that we're going to use from here on out is going to be the equal proportions method, or the Huntington-Hill method as it's commonly called. That's it. So from here on out, we're not going to play the political game anymore in this. It's going to be set, and it's going to be set from here on out. So now the question is, what is this Huntington-Hill method? And this one involves a little bit more math in the process. All right, so let's go through the math. Once you get the math, then you're like, oh, that's easy. Primarily, it's kind of like Webster's method, but we're going to use different numbers to round off. So 0.5 is not going to be our rounding off number. It depends on the population, depends on how big it is. So let's see if that helped a little bit here. So Huntington-Hill method, there it is. It's almost like the Webster method with just a slight variation. In fact, some of the time you get the same exact numbers as Webster, sometimes not. So what is it predicated upon is this called the geometric mean. Geometric mean is just two positive numbers multiplied together and then taken the square root. And pretty much the geometric means falls in the middle of those two numbers, but not necessarily at 0.5. So really what they wanted to say is this: you're going to take the lower quota, you're going to take the upper quota, and then you're going to take the square root of those, and that C value is the determining factor. So depending on the numbers, it's going to change. So here it is. Here's your cutoff points. So let's say you wanted to round off between 1 and 2. So between 1 and 2, your round off is going to be 1 times 2 is 2, and you take a square root of those numbers. So square root of 2 is a 1.418. So instead of using 0.5 like you normally did for Webster, we're going to use 1.41 to round up to 2. Okay, are we good? So if you're at 1.48, that gets you rounded up to 2. If you're at 1.42, it still gets you rounded up to 2. As you go between a number between 2 and 3, it's like, okay, do we round up to 2? Do we round up to 3? And so we say, okay, let's round up to 3. I'll take care of that little mouse issue later. Okay, so this is kind of what you have. And notice, I guess we should talk about this here. Notice the rounding is not that far off. You round off numbers if they're in the 0.4 category. Notice this is all 0.4. So if you have like a number like 3.8, you're going to round up. If you have a number like 1.02, you're going to use conventional rounding. It's only this little area from 0.4 to 0.5. It's that little 10th area there that allows you that little leeway there. All right, let's try big numbers here. Let's say you were at 42.49. So 42.49. The question is, do you round up or do you round down here? And so what you do is you take 42, which is the lower unit, right? Then you take 43, which is one more. You multiply those two guys together, you get 1,806. You take a square root of that, and you get 42.497. So if this number was 42.498, you would round that number up. But because it's 42.49, you're going to round it down back to 42. All right, so hopefully that kind of helped. So instead of just always just rounding at 0.5, we have these little numbers that break off. All right, so let's practice a bit. Actually, no, let's do an example real quick here. Let's go with the Parador's Congress. Again, here it is. Parador's Congress. So previous thing, you should have seen it before. We've done this twice already here. Okay, we're going to use, we're going to show the Webster's method in it, and then we're going to show the Huntington-Hill method, see how everything done. So here it is. So you add up the population, gets you 12 million and a half. And what you do is you look at each one of these pieces here. So if you take 32, so here's your modified quota, right? This is the way it works under Webster. And then what you do is you try to figure out, am I going to round up or am I going to round down? So anything that's not in the 0.4 category, you're going to just do what it needs to do. So 32.85, I would not even waste my time. That's going to round up to 33. Here, 138.48. Now that is in that little 4 category. So I'm going to take 138 in my calculator. So here it is. You're going to take 138. Going to multiply it with 139, and then you're going to take the square root of it. And when you do, it gets you this number. So 138.499 is what you need in order to use the cutoff to go up or down. So because 138.44 doesn't reach there, we're going to say 138 goes down or stays at 138. 3.07, don't need to do this number. So don't do this number because it's not needed. The only time you do the number is when you have that little 4 in your tens place. Otherwise, it's going to round just exactly like Webster. So 0.74 directly. There it is, 42. That's going to be a 3. That's going to be 13.67, rounds up to 14. And 19.72 goes to 20. And add these guys up, and you're good to go. All right, so it's if I was gonna just kind of do a number line, normally what we do is we look at 0.5 as the cutoff value all the time for numbers. It's called conventional rounding, integer rounding. With the Huntington method, what we do, it's kind of like this. It's if the numbers are a 0.41 to a 0.49, or you can say 0.5. It's this little spread right here. That's the issue. And so what does it really do? It allows populations with lower numbers being able to get more seats. That's all it does. Bigger populations, they need more they need a lot more of the divisor to get to there. Okay, so that's kind of how it alleviates the small populations and the large populations. Alright, so Huntington-Hill rounding numbers here. Let's go. So I'm going to go off to the side here. Actually, no. Let's go. Notice that all the numbers are at 8. So really it's the difference of, do we stay at 8 or do we go round up to 9? So what we have to do is we have to go back and look at our little chart. So for a number between 7 and 8, the rounding is 8.485. That's what it is right here. It's approximately that. And so 0.58, oh, that's easy. That's going to round up to 9. Well, I don't even need to do that little method here. Ooh, 8.485. Okay, let me think about this one here. So the chart actually said 8.485. So guess what we got to do? We got to do it on a calculator because we need more decimal accuracy. So off on the calculator. Do this here, do 8 times 9, and then take a square root of it. And let's get 4 decimal place accuracy. I'm going to do it on my calculator here too. So 8 times 9, square root. And I got myself, here's the decimal form. So 8.8485281, and then you can keep on going. But here now we at least have our decimal approximation. So notice it's 0.485281. So compare that to 8.485. We can always tack on a little 0 here. So that's going to stay at 8 because it's not higher than that little 2. All right, 8.484. Again, there's our number that we need in order to draw up and down. And 0.484 is less than 0.485, so it stays as 8. 8.486, ooh, that's higher now. Notice it's this number here. It's higher than the 5. So at this point it's going to round up to 9. All right, hopefully that helped. Just kind of getting used to rounding, because this is something I don't think you've ever rounded this way before. All right, so notice when we round with 0.5, it's just a quick, easy way to round, right? All right, and the numbers, yep, we got the same numbers here. So 9, 8, 8, 9. Perfect. Okay. Number 9. Number 9, small country consists of A, B, C, D, E states. The standard quotas for each are given. There's our quotas. Find the number of seats being apportioned. Again, got to work backwards here. And find the apportionment under the HuntingtonHill method. Oof, okay. So let's go for it here. So we're going to, for A, we're going to add up the numbers. So the number of seats in the sum of the sum quotas, if you add this up, ooh, this is kind of fun. Look at this. There's 100 seats. But the total is also 100. So that's cool. Okay, so really what happens is it's 100 divided by 100. So kind of fun that we don't need to recalculate stuff. The standard quota, because it adds up to exactly 100, is the same thing as the standard quota. So this, the divisor, same thing as a standard quota. Okay, let's go with it here. So this one, again, just kind of, it's just a working with rounding. That's all. It's working with rounding. So let's do the easy ones first here. So 14.52, that's going to round up to 15. 8.48, oh yeah, no, that's going to, I'm going to work on that later. 30.71, the easy one, that's rounds up to 71. 20.8 rounds up to 21. That's cool. So now we go use our calculator, and we're going to punch in 25 times 26. You know, my pen is not working funny. 25 times 26, and you get this answer here. And so 25.4951 is the cutoff. We have 25.49, so that's going to be rounded down. All right, so a difference between 8 and 9, we did this before. There's our number that we just got on the previous problem. We have an 8.48. And that is lower than 8.485 to 81, so we stay at 8. So round down. All right, and then that's it. There's your rounded quotas according to the HuntingtonHill method. And 50. Countries consist of 6 states, with the state populations given. The number of seats is 200. So here it is. Find the apportionment under Webster. Then also find the apportionment under HuntingtonHill. And then compare the two methods to see what you guys got. Alright, so this one, try it. You can do it kind of real quick here. You should be able just to add up these numbers. Divide by 20. And that's going to give you a standard divisor. And then you might have to modify it just a little bit. Just a little bit. You might have to go up just a little bit or down just a little bit. All right, let me try it myself as well here. So there's a little, let's see, a modified divisor. So instead of using 10,000 as a modified divisor, we're going to use, this one's actually wrong. This is 999. That's how we're, 9,999 instead of 10,000. So by that, under the Webster method, doesn't tell you which numbers would work, but at least one number would work. It looks like 10,000 does not work. It leaves just a little shy. of what you need. So if you divide all of those by 9,999, then you get this. And again, under Webster, that will round up to 35. That will stay at 20, round up, stay because it's below 0.5, and it rounds up. Okay, under the Huntington-Hill method, what happens is we calculate the cutoffs. And with this one, we actually going to use the standard quota. So 10,000 works just fine. So instead of getting 9,999, the 10,000 number actually works good. And then as we do this here, let's see. So the cutoff, oh boy, so here it is. The easy ones, let's do the easy ones. That will go up. That one will go up because it's past 0.5. But then for this one, you got to go 34 times 35, and the cutoff is going to be this. So if you want to make the cutoff column, go for it. And so I have 34.497, and the cutoff is 34.4964, so that means it gets rounded up. Alright, 20 times 21, and then take a square root, gets you 20.4939. This is 20.495. That gets rounded up as well. Alright, we know this one before, right? 8 times 9, take a square root. That's a number that's been coming up quite a few times here. So 8.486 versus 8.485, that gets rounded up. So notice all these in the Webster method would not be rounded up, but here they are getting rounded up. Alright, this is going to be 15 times 16. The calculator should get 15.4919, and we're comparing that to 15.496, and that will do it. That gets rounded up as well. So let's do this here. Let's add up these here. 35 plus, so let's add all these guys up. Let's see, that's 35 plus, oh, let me get my calculator going here, plus 21 plus 52 plus 9 plus 16 plus 70. And if you do that, it gets you 203, which is too much. There's 3 extra seats. But notice it's kind of because of these guys all got rounded up. So they're kind of right on the border. They're just right on the border, and we need some of them to be rounded down. So we're going to have to modify our divisor. And how much do we need to move? Not that much. So if we modify our divisor to just by a little tiny bit, we're going to use 10,001. That's what we're going to use, 10,001. So we calculate the cutoffs here. Again, don't need to calculate it for a whole bunch of them, just some of them, right? So let's see. As we divide by 10,001, this stays the same. No need to calculate the cutoff. That's above 0.5. That one's above 0.5. Those are going to be rounded up. But the ones that are in the 0.4 category, it's this little number right here. Once you see the 0.4, that means you know you're going to have to use the other method here. So hopefully you know the numbers from the last time we calculated it. Here it is. There's that. But now notice, using 10,001 as our divisor, notice that this now falls under the requirement. So 0.4936 versus 0.4964. So now this is going to be rounded down. Comparing 20, this is 20, let's see, this is 20 times 21, square root. And now this one is going to be rounded down as well. The next one, this is going to be, ooh, that's a close one, 0.4853 versus 0.4852. So this guy gets rounded down. And 0.4945, 4919, that is okay, that gets rounded up. And there it is. Let's take a look at this here. So now let's add 34 plus 20 plus 52. It gets you exactly 200. That's perfect. Okay, so there it is. So how, letter C, how is this method compared to the Webster method? Is that A and E are different. Under the HuntingtonHill, A loses a seat and E gains a seat. Oh, I'm sorry, hold on, let's see. That's how it's different from, yeah, that's how it's different from the Webster method. Let me go back real quickly here. Yeah, compare the two importance found in A. So the Webster method, I think it was this one and this one, right? That's where the affected were. Here's a Webster method. And notice the population. Let's take a look at the populations. So that's a huge population. That's a huge population. That is still bigger than this one. So notice A and E. And this is why we use this method. Notice the A and E. Notice that E is roughly 3 times smaller than A, right? And as I do this, notice at the end, A, which is a much bigger population, actually loses a seat to E. So it favors, slightly favors smaller populations. That's what it does here. And slightly unfavors large populations. All right, so hopefully that was useful. Do the work there, and we will, and I'll collect, if this is a hybrid A assignment, I'll collect the work that you've done on these example problems the next class. Thank you.